Let's say we're asked to draw all of the structural isomers that have the molecular formula C5H12. The word isomer means same parts, and so we're talking about the same number of atoms. All of our structural isomers are going to have 5 carbons and 12 hydrogens. Our isomers are going to differ in how those atoms are connected to each other, so they differ in terms of their structure, and that's why we call them structural isomers. You can also call them constitutional isomers. So we need 5 carbons, so for our first isomer, we could just draw 5 carbons in a chain. So here are my 5 carbons in a chain. And you should have already seen the video on bond line structures before you watch this one. So let's draw out those 5 carbons, and let's double check and make sure we have the correct number of hydrogens. The carbon on the far left has 3 hydrogens, so here we have our 3 hydrogens. Next carbon has 2. Same with the next carbon, so 2 for this one. 2 for the next carbon, and finally 3 hydrogens for the last carbon. So let's count up everything and make sure we have the correct molecular formula. So we have 1, 2, 3, 4, 5 carbons, so that's C5. And then we should have 12 hydrogens. Here's 3, plus 2 gives us 5, plus 2 gives us 7, plus 2 gives us 9, and then we have 3 more for a total of 12. So C5H12 is the molecular formula for this compound. All right, let's draw another structural isomer that has the same molecular formula. So instead of drawing 5 carbons in a chain, now we have to draw 4. So let's start by drawing 4 carbons. We need a total of 5 carbons, so we need to show the 5th carbon branching off of our chain. So we could show the 5th carbon branching off of our chain here. So let's draw in those 5 carbons. So here we have our 5 carbons. Let's count up hydrogens. Carbon on the left has 3, so 3 hydrogens here. 3 hydrogens on this top carbon. There's only 1 hydrogen on this carbon, 2 hydrogens on this one, and finally 3 hydrogens on this carbon. So let's count up our atoms. So let's use red for this one. We have 1, 2, 3, 4, 5 carbons, so that's C5. And then for hydrogens, we have 3 here, plus 3 gives us 6, plus 1 gives us 7, plus 2 gives us 9, and 3 more for a total of 12. So C5H12 is the molecular formula for this compound. So these two drawings represent 2 different molecules. Both of these molecules have the molecular formula C5H12, but they differ in terms of how those atoms are connected. They differ in terms of their structure. So we call them structural isomers of each other. All right, to draw another structural isomer, some students might say, oh, well, we could start with 4 carbons in our chain again, and this time, instead of showing a branch off of this carbon, we could show a branch off of this carbon. And so a student might draw this structure and say, okay, there's a different structural isomer. But actually, these are just 2 different ways to represent the same molecule. If you analyze that second structure that we just drew, right, the connections are the same. We have a CH right here bonded to a CH3, bonded to a CH3, and bonded to a CH2. And the CH2 is bonded to a CH3. That's the same structure as what we drew out over here. So it looks like it's a different structure, right? It's a different drawing than the one up here, but actually this is just 2 different ways to represent the same molecule. All right, so we have 2 structural isomers so far. Let's think about 1 more. So we can no longer do 4 carbons in our chain, so we go down to 3 carbons. So we start with 3 carbons in our chain. We know we need a total of 5 carbons, so we need to show 2 more carbons added to our chain, and we would have to add those 2 carbons to our central carbon like that. Let's draw out all of our carbons here. And let's add in our hydrogens. So this carbon would have 3 hydrogens. Same with this carbon. And the same with this one. And finally, the same for this carbon. The carbon in the center, right, this carbon in the center here already has 4 bonds, so it doesn't have any hydrogens on it. Let's count up everything. Let's count our carbons first. 1, 2, 3, 4, 5 carbons, so C5. And then we have 3 hydrogens, plus 3 is 6, plus 3 is 9, plus 3 is 12. So C5H12 is the molecular formula for this compound, and this is another structural isomer, so it's a different molecule from the other two. So we have a total of 3 structural isomers that have the molecular formula C5H12. Now let's draw all of the structural isomers that have the molecular formula C3H8O. And we'll start with the molecule we talked about in the bond line structure videos. So that molecule looked like this. We had 3 carbons, and then we had an OH coming off of the central carbon. All right, let's expand that out and make sure that this has the correct molecular formula. We have our 3 carbons, and on the middle carbon we have an OH, so an oxygen bonded to a hydrogen. I'll go ahead and put lone pairs of electrons on this oxygen. How many hydrogens do we need to add to the carbon on the left? Well, we need to add 3 hydrogens, so I'll go ahead and draw in those 3 hydrogens. The carbon in the center already has 3 bonds, so it needs 1 more, so we add 1 hydrogen to that carbon. And the carbon on the right needs 3 hydrogens. So let's count everything up now. So we'll start with our carbons. So we have 1, 2, 3 carbons, so that's C3. We have 3 hydrogens here and 3 here, so that's 6, plus 1 is 7. And don't forget about the hydrogen on the oxygen for 8. So we have 8 hydrogens, and obviously we have 1 oxygen here. So I went ahead and put in lone pairs of electrons on that oxygen. So the molecular formula for this molecule is C3H8O. And if I numbered this, if I said this was carbon 1, and this was carbon 2, and this was carbon 3, that helps us to draw the next structural isomer, because we can think about, instead of that OH group coming off of carbon 2, what if that OH group came off of carbon 1? And so let's draw out our 3 carbons here, and now we put our OH group coming off of carbon 1. And let's expand this out and draw the Lewis dot structure and make sure that this has the correct molecular formula. So we have 3 carbons again in a row, and then the carbon on the left is bonded to the oxygen. The oxygen is bonded to a hydrogen. I'll put in lone pairs of electrons on the oxygen. Now we need to add in carbon-hydrogen bonds. So this carbon needs 2. The next carbon also needs 2, and the carbon on the end would need 3. So that's 1, 2, and 3. When we add everything up, let's use blue for that. That's 1, 2, 3 carbons, so we have C3. We have 3 hydrogens here, plus 2 is 5, plus 2 is 7, and 1 here is 8. So C3H8, and then of course our oxygen. So C3H8O is the molecular formula. All right, next, some students might think, okay, well, we put an OH coming off of carbon 1, but what if I put an OH on the other side, so over here on the other side? So let's see what would that give us. So if I put an OH coming off of that carbon, hopefully it's obvious that these two represent the same molecule, right? There's no difference in terms of how those two are connected structurally. So this is the same molecule, so 2 different ways to draw the same one. So this is not a new structural isomer, just a new way of looking at this molecule. All right, now let's draw one more. So we can't put the OH on the other carbon, so now we have to figure out something else that we can do. Well, we could this time put 2 carbons in a row and put an oxygen in between. So putting an oxygen to break up our carbon chain. So now this would be carbon bonded to carbon, bonded to oxygen, bonded to carbon, and then we fill in our hydrogens. So there'd be 3 on this carbon, there would be 2 on this carbon, there would be 3 on this carbon, and I could put in lone pairs of electrons on the oxygen like that and count everything up. So we have 1, 2, 3 carbons, so that's C3. We have 3 hydrogens, plus 2 is 5, plus 3 is 8. So we have the H8, and then of course the 1 oxygen. So this is another structural isomer. Again, some students might say, well, we could go like this, and this would be yet another structural isomer like that. But really, this is just another way to draw this molecule. So it's not a new structural isomer, it has the same connections. So we have a total of 3 structural isomers that have the molecular formula C3H8O. And as you go further in organic chemistry, you'll learn that the first 2 isomers we talked about, so this one and this one, the ones that have an OH on it, those are called alcohols. And the last structural isomer is called an ether. So we'll worry about that more later in other videos.